Okay, so this is a quick video to do one last review for you before the chapter, which one is this? Chapter 11 test. This is all about those big formulas, law of sines, law of cosines, and also the areas formulas, the 1/2. Actually, let's go through them quick. The law of sines is especially good when you have an angle and the side across from it. So let's say this is 20 degrees and that's 12. Then we just need one more piece of information. Like let's say that this is, let's see if that's 12. This looks like it's about 20. And we can use the law of sines to solve for anything. Let's say that we really wanted this side over here. I'll put a question mark there. So law of sines is the little a over sine of big A, and little b over sine of big B, and little c over sine of big C. And in this case, it's almost better if you think of problems as not having any letters on them in the first place. And you can assign the letters where you want. So if I'm going to say that this side and this angle are across from each other, I can make them A if I want to, and I can put them in right here. And so A, the side, is 12. Sine A, that A, the big A, is this angle here, and that's 20. And then I can solve, and I can call this one B if I want to. Maybe this side here is B, and that makes this big B. And so little b is my question mark, the thing I don't know. And, oh, wait a minute, I don't have sine of big B, so I can't do this with this way. I'm going to need to change up my plan because I only have this 20 here, which then I guess is C, across from big C, this must be C. And so, since I don't have two things, you can't do it. Now, you could if you wanted to set up a system of equations, but to do it directly, we have to put in stuff we know. So in this case, why don't you give it a try here and see if you can solve by putting in C, which is an angle we don't know, and little c, which is the side of 20, put them in here, and then use this law of sines to find big C first. And then we'll use that to get the question mark. All right, I'll pause for a minute while you give that one a try. Okay, so on this one, I'm thinking we'll put in C as 20, and sine C, well, I guess we have to leave a variable in our equation. I'm going to rewrite what we have. 12 over sine 20 is equal to 20 over sine C. All right, now I'm going to cross multiply and get 12 times sine C is equal to 20 times sine 20. Then, in the spirit of getting sine C alone, so I can get the C alone, I'm dividing by 12 on both sides. Then I'll get sine C is equal to 20 times sine 20 divided by 12. And the answer to that is 0.57. Then I'm going to do inverse sine on both sides. And now C is alone, inverse sine of 0.57. And we get 34.8 degrees. All right, so we just figured out this angle right up here is 34.8 degrees. Now, if I know we have 20 and 34.8, then I know the rest because I can take 180 minus 20 minus 34.8. And it gives me 125.2. That's this angle, 125.2 degrees. So now I have all the angles. I'm going to clean this up and write down what I really know about this thing. I still don't know this side B, but I know this angle was 34.8. This angle was 20. That makes this angle 125.2. Okay, and now I do know this side is 12 and this side is 20. And now it should be enough information to get B. All right, to get B, I'm going to use law of sines again, and I'm going to say sine of 20. Actually, is there a faster way? I think law of sines is probably it. So law of sines, we have sine of 20, and I have 12 over that, equals B over sine of 125.2. Cross multiplying, that times that, and I get, okay, B is equal to 28.67. Well, I'm going to round that to 28.7. Okay, so I figured out this side would have to be 28.7. All right, took me a while, but there we go. There's your law of sines at work. And again, law of sines is best when you have an angle and the side across from it. All right, to talk about law of cosines, I'm going to look at the problems that I gave you for last night to practice. So if you have a moment right now, I'm going to have the teacher pause this video, and then you're going to get out the homework from last night, and then we're going to look at that together. Okay, so part A here of your homework from last night is the perfect setup for using law of cosines. Now, there's other ways to use law of cosines, but when you have all the sides like this, this is one of those cases where it'd be really handy to use the law of cosines. I'm just going to move this down a little bit to give myself a little room to write, and I'm going to put out that law of cosines. A squared plus B squared minus 2AB cosine C equals C squared. Then I'm going to put in my numbers. Just to keep it simple, I'm going to make A the smallest one, which is 7, so that's 49, plus B, 8, 8 squared, 64, minus 2 times 7 times 8 cosine of C equals C squared, and that's the 9. Again, actually, maybe I should be careful with this because I have it labeled with A, B, and C. Okay, I'm sorry. I'm going to use A is the 8. So, sorry about that. It is worth taking a moment and talking about this because it's labeled, and C is an okay thing, like they haven't labeled C incorrectly on this diagram. I'm going to just use their letters. So, A is 8. Across from the C is the 7. All right, so anyway, A is 8, so that's 8 squared. So we'll just go right to 64. Plus B, in this case, B is 9 because it's across from the B here. So that's 9 squared is 81. Minus 2 times A, and A is 8, times B is 9, times cosine C equals C squared. And C is 7, so that's 49. All right, I'm going to pause for a second while I grind out some math. Okay, so it's 145 there for the 64 plus 81, and then 144 for the 2 times 8 times 9. And now I'm going to subtract 145 from both sides. So I have negative 96 here. Now I'm going to divide both sides by negative 144. And I get cosine of C is equal to, well, it's 2/3, which is 0.6 repeating. Then I'm going to do the inverse cosine on both sides to find the angle. And I get C is about 48.2 degrees. All right, so once I found this one is 48.2 degrees, now I've got an angle, and I've got the side across from that angle. So I'm going to use the law of sines now. Even though I could use the law of cosines, I think the law of sines would be a lot easier. So let's see what we get there. So we'd have 7 over sine of 48.2 degrees would be equal to 8 over sine of A. Now I'm going to cross multiply and solve this one. First I would get this after I cross multiplied. Then I'm going to divide by 7 on both sides, and sine of A is equal to 0.85. Then I need to do the inverse sine, and A must be 58.4 degrees. Now that I got 2 of the angles, I think I'm done using law of sines, because if I know A is 58.4 degrees, I know that 58 and 48, those two together plus this third angle have to make 180. So I'm going to take 180 and subtract those two, and I get 73.4 for my last mystery angle right there. 73.4 degrees. If you're only off a titch, it's probably just because of rounding, so don't be too stressed about that. Okay, now I asked you to do the area on this other problem here both ways. The easy way is 1/2 AB sine of C. Note you will not use cosine there because cosine is only used in the law of cosines. So 1/2 A, which I can pick either one to be A, I'm going to call it 8. B is 7, so I'm going to call that 7. And then the sine of 50. That's all there is to it. Piece of cake. And that one is 21.4. So we just figured out the area of that is 21.4 units squared. Now, I said to do it both ways. Well, I need the other side then, this side over here, to use heroes or herons to do the area. So to get this side right here, I am now going to take a moment. I'm going to write the 21.4 up here so we can remember the answer is supposed to be 21.4 units squared. We'll see if that comes out right. So I'm going to solve now for the question mark. It's going to take me a second to find that side, but I hope you know I can't use law of sines for this because I don't have an angle on the side across from it. So instead, I'm going to use the law of cosines. A squared plus b squared minus 2ab cosine c equals c squared. And now I need to pick that the c is this angle right here. Otherwise, this law of cosine doesn't work. So that's c. I'm going to call this one a, and I'm going to call this one b. All right, so a is going to be, a squared is going to be 64 plus b, 7 squared, 49, minus 2 times 7 times, or 8 times 7, doesn't matter. And then cosine c equals, the c is unknown, c squared. And the c, big C, we do know that one, it's 50. So it's cosine of 50. Let me crank out the math on that. So I get this, then one more simplifying step, and I have c squared is equal to, c squared is about 41. And then obviously if we take square root of both sides, we would have a positive and a negative, but since we're talking about the length of a triangle side, it must not be negative. So then we take the square root of 41, so c is equal to the square root of 41, which is 6.4. Okay, so we figured out this side would have to be 6.4. Now, if that side is 6.4, now we should be able to use herons. So a quick reminder on how herons works is I need to take the semi-perimeter. Well, first I need the perimeter, which is just add up all the sides. And I get 8 and 7 makes 15 plus 6 is 21.4. And then that's the perimeter. Then the semi-perimeter would be half of that. So let's see if I can do that in my head. 10.5 plus another 0.2. I believe it's 10.7. 10, 20. Yep, that works. Okay, good. So semi-perimeter is 10.7. Now the formula says the square root of the semi-perimeter times the semi-perimeter minus A, and then semi-perimeter minus B, and then semi-perimeter minus C. So in this case, that is 10.7 times the 10.7 minus 8, which is 2.7, and then the 10.7 minus the 6.8, or sorry, 6.4, which is 4.3, and then the semi-perimeter minus C, which would be 10.7 minus, oh, I actually mixed up my C and my B, but these two being reversed really isn't going to hurt anything. So now I'm going to take my 10.7 and subtract 7, which is 3.7. Put it all together and take the square root of that big product, and we get 21.4. Thank heavens, the same thing we got before. I was really hoping after all that work it wouldn't come out to be wrong. All right, now we're going to go down and look at that ambiguous case. So first we have to assume that we have two ways this could go. This way and this way. And obviously that's a bigger angle and that's a smaller angle. So when we do this, don't freak out if we get a small angle and it seems like it should be here. It'll actually just go over there. So I'm going to pause for a second while I set this up. So really, if we're trying to find this side in my triangle, we can just start out and say I have a side and an angle across from it. This is a law of sines setup. So I go 5 over sine 35 should equal, and then let's try to figure out what that angle is. Goes with the 6 here. So that's going to be 6 over sine of, let's call it, it doesn't matter if we call it A or B or C. I'm going to call it C. And then let's solve for C. So I'll do a little cross multiplying and solving. Okay, we got it up to here. Now I'm going to do 6 times sine 35, and I get 3.44. Now I'm going to divide both sides by 5, and I get sine of C is equal to 0.69. Now we do inverse sine on both sides, so the inverse sine of 0.69. So C is 43.6 degrees. Now, as I look at this, again, that does not look like a 43.6 degree angle to me. So that's over here. This one must be 43.6. Now, if that makes sense to you, there's got to be some other angle that's over here that would also have the same answer for sine, as in sine of 43.6 right here. If that's sine of 43.6, there must be sine of something else that would give you the same exact thing. And what is that? Well, now we can transfer this over here and say, since this is an isosceles triangle, these two angles have to be the same, this one and this one. And so this must be 43.6 degrees. And then this angle right here must be 180 minus 43.6, which is 136.4. So that angle, it has to be 136.4 degrees. And if I just do a quick check on that, sine of 136.4 comes out to 0.69. Also, sine of 43.6 comes out to 0.69. So they are the same. So just double check that, and this angle right here could have been 43.6 or 136.4. So those are my two possible triangle angles. So now I'm going to use that to figure out how long is this side right here then. All right. So I'm going to clear off and get ready for that. Well, I can use law of sines in this triangle right here and say 6 over sine of 136.4 would have to equal, it would have to equal this angle going with this mystery side here. I'm going to call A. All right, so I need this mystery angle up here. Well, it's not too tough. I take 180 minus the 35 I already have, minus the 136, and I get 8.6 degrees. All right, so if that's 8.6 degrees, then I have the unknown angle, I'm going to call A, over sine of 8.6 degrees. Cross multiplying and solving, and A would equal 1.3. That's for the short side. Now, for the longer side, that's this triangle. I'm going to do in blue here. I'm going to blow it up off to the side here, kind of try to keep it in the same orientation and everything. And this is 43.6 degrees. And this angle is 35 degrees. And then we can take 180 subtracting those two, and that gives us 101.4. And now the sides we know, this one's 6, this one's 5, and this one we don't know. So I'm going to call it Q. Q is going to be the longer side option in my ambiguous case triangle. All right, so now I'm going to go, again, I got angle and side across from it, so law of sines is always easiest then. So I'm going to do sine, oops, I start with a number on top. So let's go with 5 over sine 35 is equal to Q over sine of 101.4. And now cross multiplying and solving comes out to 0.95. Oh, wait a minute, pausing. Oops, there, it's 8.5. So So Q comes out to 8.5. So that's the longer option here, the bottom of it, if it's swung out to the right. So there's an example of that ambiguous case, and that's the toughest one of them all. All right, so we have covered everything that you would need to know to do well on this test tomorrow. Remember that I am available in the mornings if you want extra help. You can go back and do, on Thursday specifically, like tomorrow morning is a Thursday in this case this year. You can come in and get extra help from me on Thursdays. So I'll be here. And you can go back and do extra practice problems. And I feel like this ambiguous case thing is one of the toughest things. If you can get that, you're going to be in good shape. All right, have a great day.